All right, everyone. So we're here at 1.6, which is parent functions. And this is actually, I think probably the biggest takeaway from these three. However, you kind of have to know the other stuff to get to this point. And so I just want to talk briefly about these. If we have more time, I would kind of actually go through each type of function and talk about all the characteristics in more detail. But basically, these are the most common functions. The step function or the greatest integer function is something that I don't see or use a lot in practice in my experience, but it's usually included on this list. But the constant function, y'all know about y equals a constant. Remember, that's a horizontal line, and that's where the slope of a line is zero. So it's actually a type of linear function. Like both of these functions are linear functions, a and b. So a constant is where slope is zero. Identity function is where slope is one and the y-intercept is zero. Okay, and these parent functions are the most kind of like basic or fundamental version of their types. So constant function, it can move up and down. The y-intercept can change, but the shape stays the same, right? An identity function, also known as a linear function, those are diagonal in nature, but remember the slope can change. They can be positive or negative slope. The y-intercept can change, so they can go up and down. And the slope can also change in terms of its steepness, right? It can change from being less steep or more steep and things like that, okay? So the absolute value function you can see here is y equals the absolute value of x. And that is actually a linear function that's mirrored on the other side of the y axis, right? Because instead of everything going negative down here, it's the absolute value. So all the outputs come out positive on the other side. And so that's what an absolute value function looks like, okay? And then a square root function, y equals the square root of x. And again, these are the most basic forms. So you don't see anything else going on, like it's not x plus 2 or things like that, right? Same thing here. So again, these are all the most basic versions of their families of functions. And so the square root function is actually a parabola cut in half and put on its side. And so like if you were to mirror that on the other side, it would actually be a parabola. The problem with it and why it can't be a parabola is because remember it wouldn't be a function because it wouldn't pass the vertical line test. And so and remember that also square roots can only come out positive, right? So you can have a square root that comes out negative. That's called the principal value of a square root. So anyway, quadratic functions, this next one down here, y'all have probably seen that before. That's a parabola shape, and it happens when you have a function that has x squared as its degree or its highest power. And so that looks like a U shape, or again a parabola, and that's an even function, as you can see, symmetrical about the y-axis. Then you have a cubic function, which is x cubed, and you can see that one here. We actually saw this a little bit earlier in an example, and so that's what that one looks like. It's kind of a parabola on one side, but on the other side it goes the other direction, right? A reciprocal function, if you put 1 over x, then you get this kind of situation where you have one side that kind of hugs each axis, right, the x and the y-axis, and then and these are called asymptotes, where it kind of gets super close to about a line, but it never reaches. And the same thing with so that has two what we call asymptotes, which we'll probably learn about a little bit later on, or you might learn about in pre-calc. And then the greatest integer function, like I said, this one's not super common, but a lot of times you'll see like this notation, and this means like the ceiling function, so it means you always round up. Or you might see this one, which is the floor function, and that means you always round down. And so this one is interesting. I think they're referring to the ceiling function, but it's a little different notation than I'm used to. But what happens in those is it basically just changes, it kind of flips it, and so instead of having the closed circle on one side and the open circle on the other, you would go the other way around, where it kind of look like that if it were the other. So that's what the floor function would look like in blue. Okay. And again, we won't use that one a whole lot, at least not in my experience. Now, a couple things. You can see that most of these graphs cross through the origin, right? So that their y-intercept is, in a lot of cases, the zero or the origin, right? Some of these don't have a y-intercept, or at least not in the parent function, like like G. And so anyway, that's one feature. You can also see some of them have like extrema, like the parabola has a minimum. If you flip it upside down, it has a maximum. Same with absolute value function. And those are both even functions, right? They're symmetrical about the y-axis, so you can see that those are both even. Whereas a cubic function, as well as a reciprocal function, those are odd functions. They're symmetrical about the origin, and so is an identity function. Also, that's an odd function. So you can see some of those different things. You can see the zeros where they cross the x-axis. You can see the y-intercepts. You can see some of the extrema, the maximums and minimums, and you can see whether they're even or odd and things like that. So those are a lot of the things that we've talked about in this really this lesson where we packed a bunch into a one video, right, over 3 sections. So anyway, thanks for bearing with me, and we'll definitely have a chance to ask questions and dig into this and practice a little bit more when we get to class. So, all right.